Hello. So today we're going to talk about the derivation of centripetal acceleration. Okay, so we are going to look at a circle like in the uniform circular motion. Okay, now we're going to look at 2 points. So 1 point here. So let's say it's going this way. I'm going to call that V1. And then in the later time, it's going to call this one here to be V2. Okay. And then we're going to draw the triangle here. Okay. And we're going to call this one here a theta. Okay. And this is radius, that's radius. You can see this is about 90 degree and this is also 90 degree. So this angle here and this angle here will be the same, right? Because both are 90 degree to each other. So then this 2R is forming 90, forming the theta. So then V2 is perpendicular to this R, and V1 is perpendicular to this R. So then this 2 will also be theta, okay? Right, so we're gonna say this is C, we're gonna call this point here A, and we're gonna call this point here B. And then we're also gonna look at this triangle here, B1. Well, it's an isosceles triangle. So it's a uniform circular motion. So V1 is equal to V2 in terms of magnitude. So then this one here is theta. And so this angle here, they're formed by V1, V2, and we're going to call that delta V, okay? So V2 minus V1, they both are vector, is equal to delta V. Right? So delta V is equal to, delta V plus V1 is equal to V2, right? So you have V1 plus delta V, which is going this way, right, is equal to this one here, which is V2, okay? So this one plus that one equal to from the tail to the head, right? Tail of the first vector to the head of the second vector is your resultant vector, right? So that's your resultant vector right there from previous chapters. Okay, so now we say these two triangles are similar. So CA, well, we're going to call that ACB, right? This triangle is geometrically similar to this angle, right? This triangle, the triangle that's formed by V1, delta V, and V2, okay? All right, so now I'll take a look at this one here. We're gonna look at, so we're gonna look at delta V divided by V, right? So V1 equal to V2 is equal to V, right? Right, because it's a UCM, which is uniform circular motion, right? So it's constant speed. So V1, V2, it's equal to V. They're all the same. So delta V versus V. So we're looking at this true triangle, okay? We're looking at this similarity, right? So two similar triangle, geometrically similar triangle. Okay? So delta V versus V. So delta V versus V, right? Which is delta L, so we're going to call this one here delta L, right? So delta L, which is AB, okay? Right? So delta L versus R, okay? All right? So we know A, right, in the radial direction, right? A in the radial direction, in this direction, right? So A in the radial direction, so radial direction, right? It's going to be the velocity's direction change, right? So it goes this way and later goes this way. So then you need something that's called delta V, which is causing the V1 to change direction into V2, but keeping the magnitude the same, right? So this is the radial direction acceleration to changing direction. So basically this is used to change direction of v, right? So from v1 to v2 basically. So this is delta v divided by delta t, okay? So that's equal to v2 minus, well, we don't need that, okay? So delta v is equal to, so here, delta v is equal to v delta L divided by R, right? So then delta v divided by delta t will be v, right? Divided by R, and then delta L divided by delta t, okay? So this delta L divided by delta t is delta L, right? Divided by delta t, it's also v, right? Delta L, right? So the distance that you travel within that time is defined by this velocity, right? Right. So distance divided by time is velocity, and that's your velocity right there. And your velocity, this is called tangential velocity, right? So this is called tangential, right? Because it's tangent to the radius, right? Tangential velocity, right? So that is v, okay? So then we have this one here, delta v delta t, which is basically equal to v times v, so v squared divided by r, all right? So we also call this one AC, okay? So C stands for centripetal. So it's pointing to the center of the circle, centripetal. So that's called centripetal acceleration. So that's what we intend to do, is derive this centripetal acceleration, okay, for uniform circular motion. That's all we have today. Yeah, until next time. So hopefully that all makes sense.